I want to remind you about the strategy when it comes to quadratic equations. So I'm going to list that big over here and call that strategy. Okay. With regards to strategy, the first thing you got to note is that part, is that there should be no fractions, right? If you have a fraction, we're dealing with section algebra and quadratic equations. If we see that there's a fraction, we should start using the LCD to eliminate the fractions. Number two is if we see there are roots, try and get rid of the roots. So, okay, and how do you do that? That's by isolating the root and then squaring both sides. Okay, number three is you need to write it in standard form, and we'll talk about what standard form looks like. Okay, and then finally you got to try to solve it using factorization, and if factorization doesn't work, then you try and use the quadratic formula. In any case, we're going to try and use this in a moment, right? Okay, so I'm going to go over the first example where we are dealing with an equation with a root. So I'm going to call this example number 1. Okay, and I've got root of 2x plus 8 minus x is equal to 0. Okay, so the very first thing we've got to note here, according to the quadratic strategy that we are interested in, is I don't see any fractions. So that's a good thing. I've dealt with that. But now I've got a root. I've got a surd over there that is the square root of 2x plus 8. And according to the strategy, if I deal with this, I got to say I got to get rid of that root. But before I do that, I need to isolate the root. In other words, I need to have the root on its own. And then I got to square both sides. Okay, so that's what I'm going to do. Okay, so how do I do that? Let's isolate the root. I'm still going to have root of 2x plus 8 on this side is equal to, there was a 0, I'm going to get rid of this negative x by adding x to both sides or taking that x over, and it becomes positive x. Now at this point in time, it's very important that we now try and square both sides, right? Okay, I square this entire thing and my result will simply be 2x plus 8. And on that side I'm going to end up with x squared. Okay, now we get all the terms on one side, so I've got a positive x squared here, so I'm going to bring all of these over. That's going to get to be negative 2x, and this is going to be negative 8, and that's going to be equal to 0. When I see that it's equal to 0, this equal to 0 is critically important. It must be there. And this over here is the standard form. This basically looks like the form of ax squared plus bx plus c is equal to 0. That's the standard form that we are interested in when we're dealing with the quadratic equation, right? And now I got to try and factorize. So I'm trying to find the factors of 8 that if I subtract them it gives me 2. And this says it's equal to 0. I open up a bracket. Factors of 8 that I must minus to give me 2. The factors of 8 that I minus to give me 2 is 4 and 2, x and x. Okay, the negative goes there and the positive goes there because this last term tells me that the signs are different and the biggest amongst them will take the negative. Okay, so where does this go? And now if I use a zero product property, I can clearly see that this implies that x is equal to negative 2 or x is equal to positive 4. Now I'm not yet done because it's possible that one of these solutions may or may not be true. So I've got to substitute it into the right hand side and then the left hand side of my equation, okay, either in this top one or this one before I've actually done the square root, okay, and then I got to see what's actually valid. Okay, so let's just do that over here and let's perform our check, right? So we're going to check the solution. I'm going to put it into root x, root of 2x plus 8. I'm going to do that there, and then the other side, when I took that over, I just had x. So when I put 4 in x, I simply have a solution of 4. Okay, and when I put 2 in there, I get 2 times 2, right, plus 8, which is sorry, it was, I'm sorry, I'm working with 4, so when I substitute the 4 in there, just erase this quickly. 2 times 4 plus 8, and that's going to give me a root of 2 times 4 is 8, 8 plus 8 is 16, and the root of 16 is 4. So clearly 4 is a solution, because when I put it in here, I get a final answer of 4, and when I put it in that side, I also get a final answer of 4. And it's important to note, just because 4 was the solution here, doesn't mean that every answer must also be 4 when I substitute. It simply means that when I substitute, I get the same thing on the left-hand side, which was this over here of the equation. If I look at that equation over there, and this was the right-hand side, I've also got exactly the same thing. Okay. When I put in -2, let's try -2. Okay, and I'm going to do that in black. 2 times, put the 2 in, times -2, this gives me -4. -4 plus 8 is equal to +4, and the square root of +4, final answer there is 2. And when I put in -2 in the x on this side, like you know, or there, it just gives me -2. Okay, when I just put in -2 in that x. So what we're trying to find here is that this clearly works as a solution, but this doesn't. And the reason this one over here doesn't is because it's telling me that 2 is equal to -2, and that is false. So we can scratch that one out, and remember, you'll get a mark for showing me that this is not equivalent. So x is not equal to -2, but it certainly does equal to 4 in order for this thing and this thing over here to be valid. So that's example number 1. Let's look at example number 2.